35 feet beneath the shifting banks of Romania's Mureș River, a construction crew dug into a compact layer of prehistoric earth. In the freezing mud, they uncovered the massive, fossilized tusks of a mastodon, an extinct Pleistocene behemoth that walked the Earth over 10,000 years ago. But right beside the prehistoric ivory, resting in the exact same geological stratum, they unearthed something impossible. It was a dense, 5-pound wedge of solid metal. It was perfectly machined, featuring 2 geometric boreholes crossing at exact right angles. It was clearly the work of a society that understood advanced industrial metallurgy. For half a century, this discovery has shattered timelines, offering a physical paradox, an Ice Age fossil and a precisely engineered metal artifact sharing the same ancient patch of dirt. It is known as the Wedge of Aiud, and to understand the impossibility of its existence, you have to understand the brutal chemistry of the metal it is made of. Gold and copper occur in nature in a pure metallic state. Ancient civilizations could simply pull them from the earth and hammer them into shape. Aluminum does not cooperate. Despite being the most abundant metal in the Earth's crust, aluminum bonds so violently with oxygen that it only exists locked inside a dense ore called bauxite. The natural world refuses to surrender it. To separate pure aluminum, you cannot simply melt bauxite in a primitive forge. You must subject it to the Hall-Héroult process, dissolving the ore in a molten mineral bath at 1,000 degrees Celsius and blasting it with massive continuous amounts of electrical current. Humanity could not generate the electrical power required to industrially manufacture aluminum until the late 19th century. Yet this machined wedge was found buried 35 feet deep, alongside an animal that went extinct millennia before the discovery of electricity. When researchers at the Metals Institute in Mureș finally subjected the wedge to chemical analysis, the anomaly deepened. The wedge was not a crude, early attempt at smelting. It was a highly engineered aerospace-grade alloy. The composition was precisely 89% aluminum, hardened with 6.2% copper, 2.8% silicon, and 1.8% zinc, alongside trace signatures of zirconium and lead.
This is not a mysterious, unknown element. To modern metallurgists, this is a very specific, recognizable blueprint. It is a 2000 series Duralumin. The copper hardens the metal. The silicon allows it to flow flawlessly into a casting mold, and the zinc adds extreme structural strength. It is the exact alloy formula used to build airplane fuselages throughout the 20th century. But if this is a modern aerospace alloy, the geological record makes absolutely no sense. In archaeology, the law of stratigraphy dictates that the deeper you dig into undisturbed Earth, the further back in time you travel. Finding a modern 20th century alloy 35 feet deep in a compact geological layer is a physical impossibility. Furthermore, the wedge was encased in a thick, deeply pitted gray crust of aluminum oxide. Early researchers assumed this millimeter-thick patina proved the object had been buried for thousands of years. But aluminum chemistry is highly deceptive. In dry air, aluminum protects itself with a microscopic oxide layer. But when a copper-heavy aluminum alloy is buried in wet, mildly acidic river sediment, a violent microscopic reaction begins. The copper acts as a tiny cathode, setting up thousands of microscopic corrosion cells across the surface of the wedge. The metal effectively acts as a battery,
rapidly eating its own surface.
Laboratory tests prove that in a highly acidic riverbed, this thick, ancient-looking crust can form in a matter of decades, not millennia. The artifact was generating an illusion of deep time. With the chemistry pointing away from the Ice Age, engineers looked to the brutal industrial history of Europe for an explanation. The first leading hypothesis treats the wedge as a broken bucket tooth from a modern mechanical excavator. While steel is usually used for excavation, steel creates dangerous sparks when it strikes flint. In environments with explosive natural gas pockets, specialized sparkless aluminum-bronze excavator teeth are utilized. But a more haunting theory comes from the sky. In the 1940s, the airspace above Romania was a mechanized war zone. The wedge bears a striking mechanical resemblance to a sheared-off landing gear pad or a structural actuator from a World War II fighter aircraft, such as the German Messerschmitt Me-262 or the Romanian IAR-80. Both machines relied heavily on forged Duralumin. But whether the object is a sparkless excavator tooth or the shattered landing gear of a downed fighter jet, the ultimate question remains: how did a 20th century machine end up buried 35 feet beneath the earth, resting directly beside the bones of an extinct mastodon? The answer lies in the terrifying power of fluid dynamics. Riverbeds are not static graveyards. They are chaotic recycling engines. During heavy seasonal flooding, the upper layers of sand and gravel in the Mureș River become a waterlogged slurry. Engineers call this liquefaction. The solid ground briefly behaves exactly like a liquid. If a dense 5-pound chunk of military or industrial aluminum was dropped into the river in the 1940s, it would not sit on the surface. During a massive flood, it would sink through the liquefied earth like a stone dropped in water. It would plummet through the geological timeline, sinking past the centuries until it hit a solid bedrock layer of prehistoric clay, the exact layer holding Pleistocene bone. The Aiud wedge is not proof of ancient alien visitations, nor is it evidence of time travel. It is proof of something much more unsettling. It represents the absolute fragility of the human historical record. We build colossal machines of duralumin and steel, believing they will stand as permanent monuments to our advancement. But the Earth is not a museum. It is a massive, violent fluid system. In the blink of a geological eye, the Earth can swallow our greatest aerospace achievements, drag them 35 feet underground, and crush them into the dirt, alongside the bones of extinct monsters, perfectly scrambling the timeline of human existence. Subscribe to ScienceTelly as we continue to shine a cinematic light on the dark, forgotten corners of the natural world.